Great. Thank you so much for that introduction, Tony Lynn, and thank you for getting things started, Will. So today, Ambrish and I are going to be talking about integrating climate change into state wildlife action plans. So for those of you who aren't familiar with state wildlife action plans, or SWAPs, the acronym that we often use, they are proactive, comprehensive wildlife conservation strategies that assess the health challenges and potential actions of each state. And they're mandated by Congress to receive funding through several grant programs. They are required to be revised every 10 years. So the last swap revision was in 2015, and the upcoming revision is next year in 2025. And states are also challenged to incorporate climate change into their current and upcoming revisions. And the Northeast region includes 13 states from Virginia to Maine, as well as Washington, D.C., which are unified under the Northeast Association of Fish and Wildlife Agencies, or NEAFWA, to coordinate their swaps to achieve region-wide and landscape scale goals. And SWAP's primary conservation targets are regional species of greatest conservation need, or RSGCN, which are species that have been collectively identified as shared priority species. So each state also typically has their own list of species of greatest conservation need, but this is a unified list at the regional scale that are high priority. So RSGCN are characterized by needing high conservation attention, prioritized investments, communication, and proactive actions. And as of this past year, there are 418 species on the list in the Northeast, and a few examples of them are shown here. So as I mentioned, the states are challenged to incorporate climate change into their swap revisions, and they've expressed some needs surrounding that. So surveys have found that swap coordinators are overwhelmed at the prospect of incorporating climate change into their swaps due to the vast amount of information coming out about climate change all the time and a lack of capacity and expertise to support climate-related planning and decision-making. They can also feel overwhelmed by uncertainty and the lack of scale-specific information about these species and habitats that they manage. So this quote, which appeared in a recent paper, captures the idea that climate adaptation is a rapidly advancing field, and unless someone is fully immersed in the topic area, it's really hard to keep up. So to address these concerns, we wrote a regional climate synthesis report for states and specifically for SWAP coordinators to have in hand as they prepare their 2025 SWAP revisions. This is the second such report, as a similar team, also led by Michelle Staudinger, Karen Terwilliger, and Tony Lynn Morelli, and others, created this first regional synthesis of climate information for states preceding the 2015 SWAP revision, and that had a ton of positive feedback. So they decided to repeat the process coming before this upcoming SWAP revision. And a lot of information has come out between 2015 and now. So there was definitely a need to continue gathering and synthesizing the resources and the studies and updated climate projections that have come out since 2015 and continue providing states with the most up-to-date and comprehensive information and allowing them to incorporate that into their SWAP revisions as easily as possible. So our report covers the period since the 2015 synthesis, and in some cases integrates some of those prior results. Okay, so to meet this need for climate change information, we had the following goals: to summarize climate-related threats to NEAFWA regional RSGCN and their habitats, develop illustrative case studies of successful climate adaptation efforts, and synthesize lists of climate-related tools, frameworks, and other resources to help the SWAP writing teams. And these goals were co-produced and refined with the SWAP coordinators, as well as the overall content outline for the synthesis report. All right, so this synthesis was put together by a collaborative team consisting of 3 subgroups. So Karen Terwilliger plays a crucial role in connecting us to the SWAP coordinators and other stakeholders, exchanging input and requests for what would be the most useful and giving feedback in real time as we develop the synthesis. And Ambrish, who I'll hand over to in just a moment, created the updated climate projections at scales that are useful for the states as they write their swaps. And then everyone came together in the synthesis and report development, which was led by Michelle Saudinger, Tony Lin, who introduced us, and Tony D'Amato, who also supervised the work of myself and two other ORISE fellows, Alice Lubeck and Kevin Bergio. And over the last 2 years, we've all been working together to produce this report. All right, so just a quick overview outline of the contents. There are 5 chapters, and we'll go into each of them here in a moment. So chapter 1 includes climate data and projections. Chapter 2 is species biological responses to climate change. Chapter 3 deals with species and habitats climate change vulnerability. Chapter 4 gathers a lot of adaptation tools and resources. And chapter 5 includes several narrative case studies as examples. And then just a few quick stats. There are a lot of numbers on this slide, but just to give you an example of the scale that we are working with, we have specific climate projection summaries for the 13 states in the NEAFO region. We've synthesized hundreds of studies on species biological responses and CCVA results, or climate change vulnerability adaptation, or assessment results. I'll get to that acronym in a minute. I know there are a lot of acronyms in this presentation. And we've gathered dozens of adaptation resources and written several illustrative case studies. Okay, so just a little bit of practical guidance for interacting with this report. All of the graphics and data in the report can be reproduced in swaps with attribution. So an example to the right, if you were wanted to reproduce a figure from the slide decks that Ambrish is going to be talking about in a moment for the individual states, there's an example of that below. The chapters provide background information and synthesis of existing data in the chapter text, and then the appendices provide specific resources for RSGN habitats and certain adaptation topic areas that you can interact with, use to extract data, and follow links to go deeper into these resources. All right, so here's one graphic, one example of the climate adaptation process. There are many kind of iterations of this process, but a lot of them follow this kind of circular structure. So from planning and considering the options to implementation and monitoring, we just wanted to highlight where some of this report fits in. So chapters 1 and 2 can inform the planning process. Chapter 3 relates directly to assessing climate vulnerabilities and risks. Chapter 4 is useful to identify potential adaptation strategies. And then chapter 5 gives some examples of how those strategies that have been implemented are monitored and being assessed over time. And then those green circles are points where the state experts will need to bring their own biological and local expertise to contemplate the climate data and the information provided and make decisions on how to incorporate that data into their respective swaps. This is very much a collaborative process, and we provided a lot of info here and are handing it off to the experts and the swap coordinators to best use that in their swap revisions. All right, and now I am passing it over to Ambrish to talk about the highlights of chapter 1.
Thank you, Anusha, and thank you all for joining in today. So I'm going to be talking about the first chapter that talks about climate change in the Northeast United States. So as Anusha mentioned, there are 2 main objectives. The first one is to summarize observed and projected climate change in the region. And then the second one is to create visual and quantitative summaries at appropriate spatial and temporal scales. And this is where we've created information, climate change information at the state level, as well as at the ecoregion scales to be useful to wildlife action plans. And then the temporal scales involved providing information about climate over the recent past, as well as how it's going to change in the near future and towards the end of the century. And we communicate this information in the form of 2 products. Again, Hanushia mentioned the first chapter, and that chapter is a written summary of all the climate change information, and it also offers guidance on how to interpret climate data that we've included. And then the second one is the series of slide decks, one for every state, and that contains state-specific visual and quantitative summary for that particular state and ecoregions within that state. Next slide, please. So since I have a very short time, what I'm going to do is I'm going to give you 3 key messages that have come out of this work. The first message is that the rate of warming in the region, it varies within the region. And you have coastal and northern areas of the Northeast that are warming at a much faster rate compared to the interior parts of the Northeast. So the figure I have on this slide shows you very clearly that if you just focus on the eastern half of the US, it's the northeastern US that has warmed substantially over the last 120 years. And if you zoom in on the Northeast, you see that the coastal parts and the northern parts have warmed more than the interior parts. And so it's, when we're thinking about planning, when we're thinking about using climate information, we have to keep this spatially heterogeneous nature of warming that we've experienced. Next slide, please. So when you think about how this is going to change in the future, what I'm showing you here are two plots. The top one shows you how temperature is projected to change throughout this century in the Northeast, and the bottom panel shows you how precipitation is going to change throughout the century. And of course, it depends on what happens to greenhouse gas emissions in the future. If we were to emit more greenhouse gases, the temperatures will rise much more. If we have moderate emissions as shown in blue, then the temperatures won't rise as much. But if you look at the temperature plot, the top plot, it's quite clear that if emissions continue, no matter which scenario we follow, Northeast temperatures are going to get higher and higher throughout the century. The situation with precipitation is a lot more complicated, and you can see that in that figure right there. We expect a steady increase in precipitation throughout this century, but there is a lot of year-to-year variability, and that's what we need to take into account. Next slide, please. And so my second message here is that seasonal and yearly variations in precipitation are more important for planning purposes than just thinking about this overall increase in precipitation. And you can imagine a situation where you have much higher temperatures in the future and abnormally low precipitation in any given season or a year, and that would lead to soil moisture droughts. Next slide, please. And so that's what is shown right here. So you can, we can possibly expect short-term droughts despite an overall increase in precipitation. You see that steady increase throughout the century in rainfall, but you still have these really large precipitation deficits, and combine those with higher temperatures in the future, and that would give you drought conditions in the region. Next slide, please. On the other hand, with warming, the atmosphere gets a lot more moisture, and so we also expect extreme precipitation events to increase in the future. On the right-hand side, you see a spatial map, and everywhere you see green colors is where extreme precipitation is expected to go up. Now, you can clearly see that there are very complex patterns, but there is a general tendency towards higher extreme precipitation in the northern parts of the Northeast in future scenarios. Next slide, please. Now, if you think about heat extremes and how they're going to change, that's one of the most obvious consequences of rising temperatures. If temperatures continue to rise, we anticipate that we will experience more days with extreme heat. And the left panel shows you how the kind of extreme hot days we experience right now and how they're going to change in the future. And of course, it changes from region to region within the northeastern US, but we don't often experience, 10 to 15 days that go above 95 degrees Fahrenheit every year in our current climate. But if we were to continue emitting greenhouse gases, then as that red line suggests, there could be a substantial increase in the number of hot days in the future. And so the left panel clearly shows you the importance of mitigation, and that's the difference between the red line and the blue line. If we were to somehow curb greenhouse gas emissions, then the risk of experiencing extremely hot days is substantially lower than if we were to continue emitting greenhouse gases. And on the right-hand side, what you see is the spatial map of how the projections of hot days are changing across the region. And the most obvious pattern there is that the low elevation regions and some of the coastal regions will experience really hot days in the future. Next slide, please. Now, in all of these patterns that I'm, or the plots that I'm showing you, it's quite clear that the climate projections are quite uncertain. And that's my third and final message, that these projections are uncertain because we don't exactly know how emissions are going to change in the future. And that has to do with socio-political issues, technology, and so on and so forth. And so climate projections by design are uncertain. And so the important message here is for vulnerability assessments and to design adaptation strategies, we must use multiple projections that span a wide range to be able to make robust decisions. And having said that, I want to mention here that even though these projections are uncertain, I would still consider them reliable. And that's because they're based on carefully selected climate models that are skillful in reproducing climate of the northeastern US. And these are also based on downscale data that have been tested for the region. And then the other point there is that they're also consistent. The projections that I'm presenting today are also consistent with projections reported previously. And so we have a lot more confidence in the information that we're providing you. So how do we communicate this uncertainty in projection? So I'll talk about that next slide, please. So in your state level reports, what you will see is lots of graphics and then tables summarizing the uncertainty in projections. So this example is specific for Massachusetts, and the table shows you, the first column shows you the number of days that we experience in Massachusetts that cross 95 degrees Fahrenheit in today's climate. And as you can see, those numbers are very close to 0 or 1. So we rarely experience days that are that hot. But the next two columns shows you how that number is going to change in the future, in the near term, in the next 30 years, or towards the end of this century. And that depends on medium emission scenario. We also provide this information not just for the state as a whole, but also for the ecoregions within that state. So you will be able to find information like this that is very specific to your state in the state level reports that are uploaded. Next slide, please. And so this is my final slide. Just want to say that the state level reports detailing climate change information for individual states, all the 13 states, are now uploaded to the project page. You can take a screen capture of this slide, or you can use your camera to capture the QR code, and that will take you directly to the project page where you will be able to see the PDF files that you see on the left-hand side that give you information about your specific state. And at this point, I just want to acknowledge the assistance I've received from the graduate students at UMass Amherst and URI to be able to do all this work. And so I'm going to stop there. I'll take questions after the entire talk, and I will hand it over to Hanusha. Thank you.
Great, thank you, Ambaresh. Okay, so moving on to chapter 2, which is all about biological responses to climate impact of Northeast RSGCN. So a big finding of this chapter were that there are large discrepancies in taxonomic and biological response research between groups and species, which reveals knowledge gaps. So some of the taxa that were climate data rich include marine invertebrates, birds, and diadromous and marine fishes. And on the flip side, some that were the most data poor include most other invertebrates, salamanders, and small mammals. And the document is organized by taxa, so it's arranged from the most to the least data on their biological responses to climate impacts. And it includes a really exhaustive amount of research, which you'll see in a second when you see how many articles Kevin and his team started with. But I just also want to mention that those knowledge gaps are really important, not only in revealing what we don't know, but highlighting opportunities for additional research, new research on understudied taxa and species, and especially relevant and pertinent to the states and swap coordinators, opportunities for monitoring those underrepresented species and taxa. So monitoring to detect and track populations in areas, especially of high exposure and projected climate change as identified in Chapter 1. So even when we don't know things about many of these species, that is an opportunity for action via monitoring and additional research. Okay, so Chapter 2 began with a systematic literature search with RSGCN names and climate keywords, returning over 7,000 journal articles in the Web of Science, which were then screened for topical and geographical relevance. And as you can see in the results, oceans far exceeded all of the other groups. And in particular, two species, the Atlantic cod and Atlantic salmon, had more studies than any other RSGCN. And I believe the monarch butterfly was the terrestrial species with the most studies related to their climate change biological responses. And as we walk through this chapter in the next few, I'm going to highlight one group as an example of how you could use this report to pull out information on a specific taxon. So we are going to talk about bats. So as you can see from this table, which there's a similar table for every taxa group in the report in Chapter 2, there's not a ton of information about bats' biological responses. Some species have had a few articles published, but others don't have any. And again, just to note, since I think this is on the text of the last slide, but this is articles since 2013. So that was the kind of boundary of the literature search. So for each taxonomic group, there's an overall summary of the general changes observed in the Northeast region, and then species-specific written summaries that synthesize the results found across these studies. And I also just want to mention that we're focused on the swaps, but this information could be really useful for a lot of different people, not only swap coordinators. So there's just a wealth of information here with climate responses of all of the RSGCN. And in terms of what kind of information is available to bats, it's mostly related to their range shifts and a few studies about shifts in phenology. So one obvious knowledge gap here, just looking at this figure, are a lack of studies on physiology, population changes, and indirect effects of climate change on bats. And as well, like I mentioned, a few species that don't have any studies as well. So one example, the Indiana bat is predicted to shift drastically in its distribution over the next several decades, moving from the Midwest to the Northeast, due largely to climate change, specifically temperature. These figures are all from a paper that's cited in Chapter 2, and the results are synthesized there. So on the left, the figure is showing the current range of Indiana bat maternity colonies and their habitat suitability based on current conditions. And then in the center, you can see in a few different time scales and a few different climate projections. As Ambrish mentioned, it's really useful to use different projections because we don't know exactly how the climate is going to change going forward. But you can see in blue the areas where Indiana bat is projected to lose habitat, and in red, areas where it's projected to gain suitable habitat. So this is the kind of information that you can find about range shifts for this species. And another example, another bat species, the hoary bat. So one study found that this bat species, which roosts in a warmer microhabitat in foliage, has a higher heat tolerance than other bat species that roost in more protected areas, like bats that roost in tree crevices. However, hoary bats preferentially roost in eastern hemlock, which is currently experiencing drastic declines in the Northeast due to the hemlock woolly adelgid. And in turn, the hemlock woolly adelgid is expected to expand further in the Northeast due to climate change. So that's kind of an example of one of these kind of cascading, direct and indirect effects of climate change coming together in various ways. All right, moving on to Chapter 3, the Northeast RSGCN and habitats most vulnerable to climate change. So in this chapter, we talk about some basics of what is climate change vulnerability. Very briefly, we characterize it through three components of exposure, sensitivity, and adaptive capacity. We also spend a lot of time talking about climate change vulnerability assessments, or CCVAs, which are goal-oriented decision support tools that help managers determine which species are vulnerable, how vulnerable they are, why, where, and when they're vulnerable. And we highlight recent advances in the field of CCVAs, types of CCVAs and their pros and cons, and as well as discuss other types of risk assessments. And we also talk a lot about how to interpret the information in a CCVA. So I'll again get into this with a bat example shortly, but this figure really sums it all up, but we go into a lot more detail in the chapter text. But there are a lot of things to consider when you're looking at a CCVA that ranked a certain species as vulnerable or extremely vulnerable, and what does that mean? So there are a lot of pieces to consider, including how they define vulnerability, because that does vary between reports, which methods they used to assess vulnerability, the geographic and ecological scale, and the time scale and the climate scenarios, as well as any non-climate variables that might have been considered. So like I said, there's a lot more detail about this in the report, but I'll also show you how we summarized some of this information for you about the CCVAs that we included in the synthesis. And then as for the actual CCVA results, birds and fish were the most frequently assessed taxonomic groups of all RSGCN, and crustaceans and marine invertebrates were the least assessed groups. So just to point out that marine invertebrates were one of the most represented groups in Chapter 2 in their biological responses data. So that maybe seems like an opportunity to incorporate more of that research on biological responses into a better understanding about marine invertebrates' vulnerability to climate change. And on the habitat side of things, forests and woodlands and tidal wetlands and flats were the most assessed habitat classes overall. And of course, there are a lot of different types of habitats within those larger groupings, but subterranean areas and Great Lakes were the only natural habitat classes with no CCVA results. So that represents a gap in our understanding of their climate vulnerability in the Northeast. And one thing I want to point out, which again, I'll talk about as we go through the example, we aggregated CCVA rankings on a unified scale of sorts. So because every CCVA, every study is slightly different in the methods that they use and how they chose to kind of rank vulnerability, we put them all in kind of common terms as a starting point to look at these different results and compare them or just kind of have an overview. But it is really important to consider the original context of the CCVA. And again, we'll give an example of that here. But I just want to mention we did put them on a unified scale, but we also included all of the original context as much as possible within the tables and the appendices to show that there's all this important contextual information that goes into that ranking. So talking about bats again, if we first just want to know which bats are ranked in CCVAs, which bats have been assessed for their climate change vulnerability. So this table and all the tables that I'll show in the next few slides are just pulled directly from our appendices, which are in an Excel file with data slicers and pivot tables that you can really manipulate to get the data that you're looking for. So I don't have time to do like a full interactive demo, but there are a lot of tools built into that appendix to help you interact with the data and find what you're looking for. And hopefully I'll show some of what that looks like. But all of these tables are from that Excel sheet. So I just want to mention that. So looking at the 9 bat species on the RSGCN list, 8 of them are ranked at least once in relevant CCVAs. And actually 4 of those species have only been assessed since 2015. So those are new rankings, but we also did include the rankings that were in the 2015 synthesis report as well, so that you have all of the information, even if it was before 2015. And then if you want to know how those bats are ranked, so as a group, they're ranked 35 times in total, with 10 vulnerable rankings or 20 vulnerable and 10 presumed stable rankings. And those terms come from our kind of unified scale, as I mentioned, which is just broken into these 5 categories. But then if you want to look more in depth at the individual species, you can see the breakdown of the species vulnerability rankings and the geographic extent of the CCVA that they came from, because that's definitely, I think, one of the first things that people want to look for is, okay, well, where were they looking at this species? So let's take another species for an example, the tricolored bat. There are 3 rankings, one from a CCVA that's focused in Maryland, one in Massachusetts, and one in the Ontario Basin, which technically is in Canada, but because it borders some of our NIAFO region, we decided to include a couple that are outside of the NIAFO region, but bordering and maybe useful. So again, going back to these considerations, the geographic area is definitely one, the geographic scale, but these other things you want to know about what made them rank the species this way. So this is another kind of version of this table that gives some more information about the original ranking of that CCVA and then the citation for it, which then you can go to Appendix 3.1 and find the CCVA that ranking came from. And we broke down for each of the CCVAs released since 2015 that we included in the synthesis. We broke down as much as possible those considerations so that you have kind of at a glance the the scale, the time frame, the climate models that were used in that assessment, and to help you interpret those results. And then whenever possible, a direct link or information on where to find the full citation for that CCVA, so you can go back to the original source document as well. Okay, and then moving on to Chapter 4, Climate Change Adaptation Strategies and Resources in the Northeast US. So over the last 10 years, the field of climate adaptation has advanced from establishing theory into implementation. And the chapter text highlights 9 decision support tools, 17 action menus, and 9 emerging topics in climate adaptation. And it also includes several in-depth walkthrough examples of applying some of these tools to various scenarios. And then the appendix for Chapter 4 includes dozens of additional resources, action menus, and case studies for your perusal. So again, going back to bats, one example of one of those kind of walkthrough demonstrations of how to use some of these adaptation tools is in the climate amplifier vignettes. So these are demonstrating how you might integrate climate change into SWAP planning by looking at climate threats that are amplified by non-directly climate-related threats. In this case, renewable energy, you might consider that kind of an indirect result of climate change in some ways, but it's not, a direct effect of climate change. So this climate amplifier vignette looked at the effect of renewable energy amplified by habitat change and its impact on several bats on our RSGCN list and the habitats that they live in. So some key points from the taxa team experts. Increased wind energy development will potentially decrease bat RSGCN habitat, and changes in bats phenology may make it difficult or impossible to create a wind curtailment schedule to reduce bat mortality at wind farms. So that's kind of the crux of the problem. There's a lot more information in the report itself, but to go through one of the possible solutions, one solution or attempt to manage this problem would be proactively curtailing wind farm activity when that activity is high. And that corresponds to a couple of different action menu strategies from menus including the terrestrial wildlife adaptation menu and the tribal adaptation menu, both of which are discussed in this chapter, as well as several other menus and decision support tools. And as you might remember from Chapter 2, we don't know a lot about how climate change is affecting bat phenology. That is somewhat of a data gap. So this might be kind of a multi-part solution where we first need to learn how bats phenology or their activity might be changing, and then use that knowledge to inform how we're managing wind energy and wind farms to minimize bat mortality as much as possible. So this is just one example of how those adaptation resources can be used to connect and draw from those other chapters and inform the planning and adaptation process. Okay, and then finally, Chapter 5 is really an extension of Chapter 4, and it includes 4 more in-depth narrative case studies at different geographic and management scales, from forest management at an individual wildlife management area to coordinated efforts for region-wide disturbances. So I'll just touch on one of the case studies to continue with the bat example. So none of the case studies were actually about bats, but this one does have a connection. So New Jersey's Sparta Mountain Wildlife Management Area used several NIACS adaptation menus and attended some adaptation workshops to help inform the revision of their forest stewardship plan for the WMA. And Sharon Petzinger, who works at Sparta Mountain in New Jersey, was the person who contributed this case study. So I want to acknowledge her, and she also attended these workshops and was really involved in this process. So they discussed and considered how to balance benefits both to carbon storage and wildlife habitat, and finding compromises or thinking about the trade-offs where those goals don't always necessarily align. So for example, hemlocks on the property are threatened by the hemlock woolly adelgid, as I mentioned earlier, but they provide really important habitat to species, including hoary bats. And proactive management of hemlock woolly adelgid might not be the kind of optimal maximum carbon storage, but it does retain important and unique habitat for wildlife species. So that's kind of an example of how in real time managers think through these problems and solutions and use that to inform their management process. And of course, there's a lot more to this case study, which you can read in chapter 5, but this is just one example of how it ties into that. Okay, so going back to this climate adaptation process, as I mentioned at the beginning, but hopefully it's a little bit more, now that you've seen kind of some highlights from each of these chapters, you can think back to how they inform several steps of the process. And again, are kind of leading into and through the steps that are spearheaded by the state experts and are incorporated into the SWAP revisions and into management and adaptation activities in the states going forward. And to kind of sum it all up, this report is really a choose your own adventure. So I kind of took us on one adventure relating to bats, but there's so much information, as I mentioned. There's a lot about many different taxa, and there's also a lot more to explore and to dig deeper on your own. So for example, there aren't climate threat amplifier vignettes for every single possible interaction of climate and another impact on species, but there is a lot of information in the menus, in the decision planning, decision support tools, and adaptation resources for you to take from the chapter, what interests you, what might work for you, and then dive deeper into those resources and into the CCVA results and the biological responses data. So we're really summarizing things here and kind of putting it all out there as a buffet table of information for people to choose what is useful for them. So you might use chapter 1 to understand how key drivers are changing and where the greatest change is occurring within the region or within your state even. Chapter 2, you can review available information on species-specific responses to climate. In chapter 3, you can determine if a climate change vulnerability assessment has been conducted for your species of interest. If yes, where, when, and under what conditions. And then take all of that information, and in chapter 4, you could revise an existing action or develop a new action using menus and other tools that are really well described in chapter 4. And then in chapter 5, you can explore case studies and find inspiration for implementation. So we don't expect you to read this report cover to cover. And it doesn't have to be a linear journey. So you can go back and forth between chapters, find what works for you, pull those figures and data, as we mentioned, directly from the report, as long as they're attributed back to the synthesis. You can use those figures directly and just use what works for you. All right, so as Ambrish mentioned, the report and the slide decks and the appendices and the data products that are associated with it are now available on ScienceBase. The main points of contact for the synthesis report are Michelle, Tony Lynn, and Karen, who I mentioned earlier. And I put my own and Ambrish's contact information up there as well. And also wanted to mention that Michelle Staudinger also contributed and created some of these slides. And I also just want to mention that all of these chapters individually had many, many other contributors and their other authors in addition to the overall report author. So many, many people contributed to the creation of this synthesis, and we are really grateful for all of them. It has been a 2+ year process, I guess even longer for the Michelle and everyone who wrote the grant to create this synthesis. So thank you to everybody who contributed to the report, and thank you to all of you for being a great audience. And I also just want to shout out our upcoming presentation at the NEAFL conference on April 24th. So Wednesday morning, we have a special session all about this report, going even more in depth than we could in 45 minutes. So thank you all for listening. And I think with that, we can move on to the Q&A.